So here we are solving best time to buy and sell stock problem. The problem statement says that we are given an array and we have to figure out on which day should we buy and sell the stock, and we have to return the maximum profit that we are gaining from this. So let's see some examples. So the first example says that we have an array 715364 and these are representing the stock value for each day. So on day 1 the stock value is 7, on day 2 it's 1, on day 3 it's 5, on day 4 it's 3, on day 5 it's 6, on day 6 it's 4. So we can pick on day 2 where the stock value is minimum, and we can actually sell on day 5 where the stock value is 6. So if you will be subtracting your day 5 selling amount with your day 2 purchasing amount, you will get your profit, which is 6 minus 1 is 5, and this is what we have to return. Okay, in the next example we have array with 76431. Here it's in decreasing order. So let's suppose if we choose to purchase even on this day, day 3, so there is no other day where we will be gaining the profit because no other value is greater than that. That's why we are returning 0. Hence the minimum value is on the last day, but we cannot sell it. That's why we are returning as 0, right? So the most straightforward approach that I can think of is to apply two nested loops, one running from the starting towards the end and the next one running from starting plus 1 towards the end, which is the ith loop will be running from 0 towards the end and the jth loop will be running from 1, I plus 1 towards the end. And now we will be actually comparing if my array of jth, if my prices of jth element, if it is greater than the prices of ith. So in this case we can actually do the comparison and we can update our maximum variables, and this is how we can track the output. Okay, so if you will be presenting this solution to your interviewer will not be happy and will be asking you to further optimize it. Now here comes our second approach. So instead of nested loop traversals, we will be actually traversing the array only once, and in the traversal we will be figuring out two things. One is calculating the minimum so far and then calculating the profit out of it. So let's see. In the traversal, let's suppose if we are at this point, the third day. So now the minimum till here is 1, and now we have to calculate the maximum profit, which is the current element, which is 5 minus the 1, which is the minimum element. So that means we have a profit of 4 if we will be selling on day 3, right? So this is how we will be actually figuring out and updating our maximum values. Stay tuned towards the end of this video because the second approach that we just discussed, we will be solving it with the ES6 way. Okay, approach 1. So as discussed, we will be actually maintaining two nested loops. So let me traverse from the starting towards the prices length, and in the nested loop we will be traversing from I plus 1, and now we'll go towards the prices length. Okay, now I'm gonna compare the prices of j if it is greater than prices of I. So if we found a greater element, we'll do two things. One is, let me bring up the profit. So the profit will be prices of j minus prices of I, right? And now I am going to compare with my maximum. If my maximum is less than this profit, so this means that I need to update my max to be this profit. And since we are using it down, we will also declare it as 0, and after the nested loops we'll return the max. Okay, so far so good. So let's execute the custom test cases. It passes. Let's now try to submit this problem. So as expected, we are getting time limit exceeded and our 200 out of 212 test cases are passing, and this is where we have to go to the next approach. Okay, so the next approach, as promised, it will be a combination of ES6 and would be an optimal one. So let me name as approach to ES6 way. Okay, Let me just expand this code editor for the approach 2. Now what we'll do is, let me just declare two variables, which is min day equals to number dot max value. We can even use infinity, and next is our profit, which will be 0 at the start. Now we'll use a for off loop, which will be price of prices, and now we'll compare the min day with math of minimum, the min day comma the prices of I. So we'll get the minimum value till now. In order to get the profit, what we'll do is math of maximum of the profit, current profit, and my prices of I minus the min day, right? So in this way we will be getting the minimum value, and now simply we'll return our profit. Simple enough, right? Let's execute the custom test cases. Okay, it's prices of, oh yeah, it should not be prices of I, my bad, it should be price. Okay, it's working. Now let's submit this. Cool. So we are able to solve this problem via ES6 way. Okay, let's comment this and analyze the time complexity now. So time complexity for the approach 1, this one, yes, you are right, it would be order of n square. And what about the space complexity? Yes, it would be order of 1 only, because nothing major we are doing here. Okay. In the next, we have just one traversal, which will give us order of n time complexity, and for the space complexity, again it will be order of 1, right? So again, this will be the most optimal solution that we have to present in front of the interviewer, and the interviewer will be happy with this. And that's all. Thank you.